Hello, I'm Jim Salisbury with Mitutoyo America Corporation, and welcome to the Metrology Training Lab. In this episode, we're going to talk about traceability, or sometimes called metrological traceability. Here's the question that traceability answers. Say I make a measurement with this caliper. How do I know that the inches or millimeters on this caliper are the same as everybody else's inches or millimeters? How do I relate this measurement back to some defined standard, like the definition of the meter or the inch? Clearly, traceability is critical in measurement. So how do you ensure it? This is not a new problem. Over 5,000 years ago, in ancient Egyptian culture, they understood this. Their standard was the cubit. It looks something like this. And their traceable calibration system helped enable them to build some amazingly accurate structures like the Great Pyramid. While the cubit and its history is pretty cool, things got even more interesting in the late 1700s with the birth of the meter, which eventually led to the entire metric system known as the SI system of units. So back in the late 1700s, a bunch of moderately crazy scientists decided that a new standard of length, the meter, needed to be based on something that we all own together, and they chose planet Earth. They measured the circumference of the Earth, and a fraction of that was used to establish the meter. But what was most important was that countries all around the world agreed to use this meter. So here's how traceability worked then. In a high-level government lab near Paris, France, they had what was called the official prototype meter. It was a bar made of a special platinum iridium alloy, and then other similar meter bars were made and compared to that one. These bars were sent all around the world. In the United States, we had meter bar number 27, which was used to disseminate length traceability across our country. Our meter bar number 27 is in a museum now. We don't use it anymore. As technology advanced, the world needed something better than passing around metal bars. Today, the meter is defined on how far light travels in a very short amount of time in a vacuum. So basically, anybody can create their own meter. All they need is a stopwatch and a light. Well, that would be a really accurate light and a really accurate stopwatch. So maybe most people can't do that. But here in the United States, a group of smart scientists take care of that for us. They work for the US Department of Commerce at a place called NIST, the National Institute of Standards and Technology. They do a great job on this important task for our country. So let me just say thanks to all those smart men and women at NIST who take care of this for us. But how exactly are the measurements made using this caliper traceable to the meter or inch at NIST? Let's walk through an example. Say this caliper is used at some manufacturing organization, and they calibrate this caliper themselves in-house using a caliper checker, something like this. To calibrate the caliper checker, the company then sends them to some local calibration lab. And that local calibration lab, who has their own gauge blocks, then sends these gauge blocks to a higher level primary calibration lab, like the one that we have here at Mitutoyo America. The company that owns the caliper doesn't send their caliper checker to NIST. The local calibration lab doesn't send their gauge blocks to NIST. The reason for that is simple. They don't need that level of accuracy, and they sure don't want the cost and lengthy turnaround time at NIST. However, here at Mitutoyo America, being a higher level lab, we send our master gauge blocks to NIST. And then internally here, we calibrate what we call our working masters against the NIST calibrated masters. And then the working masters are used daily to calibrate customers' items. In the end, our master gauge blocks are actually used very infrequently which allows us to absorb the NIST turnaround time and also helps preserve our masters for decades of use. At NIST, our master blocks are then compared to their masters, which are in turn compared to laser systems which are directly linked to the realization of the meter at NIST. So it goes from NIST masters to their gauge blocks, to our masters, to our working masters, to the local lab's masters, to the customer's caliper checker, to the customer's caliper, to the parts being measured on the shop floor. And that's traceability. But how does the owner of this caliper trust that system? They are relying on a chain of multiple calibration suppliers to ensure the quality of their measurements made with this caliper. The best way to ensure rock-solid traceability is to use what we call accredited calibration laboratories. The use of accredited calibration labs is required in many industries, but even if not, it is highly recommended. The standard used in accreditation is called ISO/IEC 17025, and it is an internationally recognized standard for competency in calibration and testing. Now, to become accredited, a laboratory must demonstrate traceability. They are also audited regularly by measurement experts to see if the work is being done correctly, and they must produce what's called a scope of accreditation, which defines what they can do and how well they can do it. Scopes are publicly available documents and are usually found on organizations' websites. You can also easily find them on the website of the different accreditation bodies. So this is the scope from Mitutoyo's accredited lab. If you're wondering if we can calibrate gauge blocks, then just look on our scope. The scope also lists what's called the CMC, or the Calibration Measurement Capability, which is a measure of how well our lab can calibrate something. The CMC is also sometimes called the Best Measurement Uncertainty. Now, we're not getting into what uncertainty is in this episode, but let's just say that a lower uncertainty or a lower CMC means the lab can measure more accurately. Scopes are pretty powerful and a very easy way for you to vet calibration suppliers, or as I like to do, to spy on my competition. So I hope you've learned a bit about traceability and accreditation in this episode that will help you manage your calibration systems better. Thank you. I'm Jim Salisbury, and I'll see you next time from the Metrology Training Lab.